Alright, I'm gonna try to make this quick. So yeah, this is uh, this is a video on how to do arithmetic with Boolean algebra. Sounds pretty smart. Okay, first, to not waste any of the people who already know this and just want the equation. It's not really an equation, but on how to do it, it's like this. The new number you'll get will be n1. Wait, I think I forgot something. Okay. Oh, let's just assume. I have confirmed this method works, and this is actually how they do it in Google Images. Whatever. The first thing you will get is that you do XOR the first two digits, and then XOR again with the previous carry bit. And how you get the next carry bit is a little bit more complicated, but you get XOR these first two numbers. I should have just called them X and Y, and C, n1 XOR n2, and then you do and those two, or you do an OR of n1 and n2. I'll go into how I found this right now. But first, we need to look at what these dang Boolean algebra is. What does it mean? Pretty simple. You have two inputs. It doesn't matter what they are. They could be 0, 1, A and B, X or Y, true, false, yes, no. Doesn't matter. They will return a single a new value based on 2 or 1 in the case of not, that you will need. As you saw in the previous thing I just showed, and or and XOR are going to be the only things that matter, and an XOR are really important. Or is a side thing. I'll explain later. Whatever. You let me first describe how AND works. And well, it's only 1 when A and B are equal to 1. That's why it's called AND. Or is only 1 when B or A is 1. If both are 0, then it's 0. And XOR is only 1 when XOR is only 1 when A and B are different inputs, and it's 0 when A and B are the same. Okay, that's all you need to know. Let's go into Boolean adding numbers, adding binary numbers. Okay. Works as simple. In my case, I'm going to do 5 plus 6. I'll just show you the process of adding binary. So 1 plus 0, that's 1. 0 plus 1, that's 1. 1 plus 1, that's 2. But binary does not have 2. It can only do 1 or 0. So you would have to do a carry. This would be 0, and now you have 1. And that will give you, that's 11. Okay. Hopefully, now that you understood this, we can begin to translate that into, we can begin to translate that into normal, not translate, but you know what I mean. Put it through Boolean operators. Yeah, that's what I mean. We can say the first number is X, Y, Z, and the second is X1, Y1, and Z1. Okay. An interesting property that you might find is that if the first two are the same, whether they be 0, 0 or 1, 1, you'll always get 0. In the case of 1, 1, you'll have a carry. But if both of them are the same, then that would be 0. But if they are different, that will give you 1. this is why you need XOR. Let's do X in this case. X1, you do X, XOR. I probably shouldn't have used XOR. It's a tongue twister. X XOR X1. Okay. That will look like this. Okay, that gives you your new number. What's the carry bit then? Well, this is where AND comes in. The carry bit, if you notice, you only get a carry bit if the first digit and the second digit are 1. So that fits with AND. 1 and 1, that will give you 1. So, like I did here, let me bring all this back. I don't know why I deleted it. Okay, so to get this new thing, you would need to put it through AND. I believe that is the gate for AND. Yeah, and so it would be X, X1. There you go. That's your carry bit. But this is not complete. This is only true for the first two. It does not account for the previous carry bit. In the case of the first thing, the carry bit will be 0, but we need to account for it with a new. So we still keep this. Probably I ought to make it nicer. Man, okay. We keep the previous thing. What? I'm trying to do this quickly. I got other stuff to do. I hate history. Yeah. So you get X, X1. You put these two through XOR. But to account for the carry bit, you will need to okay, first let's call it carry bit C. Now this will be your new number. Let's call this X2. But with the new number you're gonna have to add it to C. And C, well, you just do that by doing XOR again. Okay? And you can also try to find the carry bit between C and X2, this new one. And you do it by the same thing. So you do C and X2. Because only if those two are 1, then you get a new one. So, it's ugly now. This doesn't look pretty. But you make do. Okay. Well, this is going quicker than the last one. Well, what's next? Oh yeah, now I have to explain why you do OR here. And there's a pretty simple explanation for that. Notice how you can only get, let's look at this case. Let's add these two first, and this top one is the carry bit. Notice how you'll have to notice how you can't have a carry bit with these two and then add C and then get a carry bit with those two. These two cannot be 1 at the same time. Now why is that? Pretty simple. Okay, let's do the case where they're all equal 1. You add these two first, okay? You get a carry bit here. So X and X1, X and X1, yeah, are 1. So you get a carry bit and then you get a 0 down here. Okay. Well, then now you have to add the carry bit. And that will just give you 1. You do the carry bit, X or X2, that's 1. And you do it and, well, that gives you 0. 0 and 1, that's 0. So that goes here. They can't be the same. So let's say we do it the other way then. Let's say put this here, 0, 1. Okay, well, you add these two, you get 1, but you get no carry bit. So this would be equal to 0 right here. But once you add the carry bit, you get a 0, you get a 0 again. But you also get a new carry bit. So so the reason why we do OR is to, well, if this one is equal to 0 or this one is equal to 1, you still get 1. And if it's flipped around, you also still get 1. But if both are 0, then you get 0. 1 and 1 does not matter because as we just said, they cannot be the same. Boom, that's the fastest I've done this video. Let's see my time. 11? Oh, I thought it'd be more like 7 minutes. Oh, new record for me. Let's go back to the original expression. There is, I forgot to do the black box thing or show you the table. Whatever, you probably got this. The table would look like this. You know, add all 3 zeros, you get 0, 0, 0, 0, 0, 1, 1, 0, whatever. You understand. I really didn't need this table to show you, but I did it to understand myself. So that's what matters. The original draft I had was, well, then you take this big box that will give you, and then you would insert the first 2 digits, and you'd get a carry bit, and you'd get a new number, and then you'd put it again through an adder. Okay, you get a carry, but here's the thing. You'd also need to the new number doesn't go through the adder, through the new adder. But you do get a carry bit. So the carry bit would have to go through the adder. Why is this? A, B, C. Let's also do this one, X, Y. Now, why? So we would also need a carry bit here. So we could have a repeating series. I'm not gonna do this too long. So we would put this all the way at the end. Now you would have N, N2, and C. And it would look like this. And yeah, so you would have to have repeating, these things have to repeat, you keep putting them, and the new things will go here. You could see the pattern, right? And each one of these are another digit. So I think that's pretty much it. Yeah, and I checked and I looked this up, and my method seemed to be the one that worked. I'm proud of myself, but this was surprisingly easy. It only took like 15 minutes. I don't know why the teacher didn't teach this. But that circuit sure does look ugly. I'm gonna look it up again, see how it does. Yeah, this is the one. This is the one I drew. Some carry out. I think that's what that means. Again. Yeah. This is the original thing, so I guess it's called the half adder. I find this one interesting. I think it's really clever. Because you can keep doing that. I think that's all. Sorry for taking too long in making this video.